Hello, everyone. Mr. Minix, my name. Math is my game, and today it's a gloomy Monday morning. Actually, the sky's quite nice, but here we are. We're almost at the midpoint of the chapter, and the title, bless you, the title is Chapter 4, Section 5. We're going to be solving quadratic equations, and there's two techniques we're going to look at today. One of them, graphing. We're not going to focus too much time on this, but everybody should have a calculator before them, and so we will look at how to solve by graphing. And the primary thing we want to look at today is solving quadratic equations using a technique known as factoring. So by factoring, just to kind of a quick glimpse, what you're going to, or I'm sorry, by graphing, to solve, what you're going to do is you're going to graph, and you're going to find the x-intercepts. You're going to find the x-intercepts. Okay, that can be done in several ways. Sometimes it'll be real clear what your answer is. Sometimes you're actually going to have to use some special eyes. Sometimes you'll have to use the analysis feature, and you could use find x-intercepts. And there's something on the TI Inspire that's actually a lot more seamless than that, a lot easier to use than the analysis and finding x-intercepts. It's actually called the graph trace. The graph trace. Okay. If you use graph trace, that would be the ideal way to go about doing that. So if you ever have to solve a quadratic equation, what you do is you make a function out of it, you graph it, you find the x-intercepts of the functions of the function, and that's the same thing as the solutions to the equation. So we'll look at one of those, maybe two of them, maybe three, or probably just two. There you go. All right, we ready to do this? Ready or not, here we go. Example 1, solve x squared minus 5x minus 8 equals 0 by graphing. So we're going to solve this by graphing. So first things first, this is an equation. It's not a function, so we might want to kind of have an understanding of how we could write this as a function. Anybody have any ideas what this would look like as a function? Equations have equal signs in them. Functions usually have a y or an f of x equals. So we could say f of x equals what? Any ideas? X squared minus 5x minus 8. Okay, so I don't know if you can see the difference between those two things, between this and between this, but if you can't, I'm going to point it out. The only difference is the 0 is replaced with an f of x, or f of x takes the place of 0. Now we said f of x and y are kind of like the same thing. So hopefully this explains why it is that when we go ahead and graph one of these, the graph's going to probably look something like this. And our answers are going to be the x coordinate of the function whenever the y value is 0. Okay, so if you can't see this, I hope somebody makes this connection that what we're doing is we're finding the zeros of the function. We're finding the zeros of the function. We're finding x values when the graph of the function has y values of 0, when the graph goes through the x-axis. Okay. So if you haven't graphed this on your calculator yet, I don't know what you're waiting for. Let's go ahead and graph this on our calculator. So we'll want to do this from a graphs page. So from a graphs page, I need to get a graph page, so I'm going to insert a graph page. So we got x squared minus 5x minus 8. So looking at that, it looks like the graph's going to go through the x-axis twice, which means we're going to have two answers. Let's just see if I can't take a picture of that. Try to get a snapshot of that. We'll go ahead and send this right to the current page here. All right. So my answers, it looks like one of them is going to be right here. It looks like x is going to be approximately negative 1 point something, right? Can you see that on your graph? Okay. And the other one, let's see, 1, 2, 3, 4, 5, 6. X is going to be approximately 1, 2, 3, 4, 5, 6, 6 point something, right? So what we need to do is we need to use the trace graph trace on this. So we'll go menu, trace, graph trace, menu, trace, graph trace. Now the awesome thing about menu, trace, graph trace is the cursor will stop at critical points along here. I'm just using my directional pad, and I'm just going to arrow to the left a little bit. And there's my first 0. X is about negative 1.27. Okay, about negative 1.27. About negative 1.27. Okay. And if I keep on cursoring over the other way to the right, it looks like that the other one is about 6.27. About 6.27. Okay. So one thing that I should probably point out is a lot of times the decimal portion of these answers is going to be the same. I'll say that again. If these answers end up with a decimal part, a lot of times the decimal portion of these answers, especially if they're irrational, it's going to be the same, and you'll find out why later on in the chapter. It has something to do with radicals, with square roots, because your answer is going to be something plus or minus the square root of something. And so usually that decimal part's going to be the same on fractional answers. Well, I won't say on fractional answers, on answers that have a decimal. Better not say on fractional answers. Are there any questions so far? Was everybody able to find those two values of x on their calculator, I hope? Cool beans. Well, let's try another one. The next one we'll try, example 2, solve by graphing x squared minus 5x minus 6 equals 0. So again, we need to kind of think of this as a function. So f of x would be x squared minus 5x minus 6. You don't have to write that every time, but think of it that way. And remember, we're finding the 0 of the function. We want to, in effect, replace y or f of x with 0. Now, I can look at this and I could tell you right now what the answers are going to be. I don't have any tricks up my sleeve. I don't have any weird alien implants inside my brain, although I like to tease around and say that I do. But I know that one of my answers to this is going to be 6, and the other one's going to be negative 1. I could tell that just by looking at that. And that's going to segue into the next part of this lesson. So let's go ahead and graph that. The cool thing is I can go ahead and just hit tab on this graph, and I can go ahead and just change this function. So minus 5x minus 6, there we go. And it looks pretty clear what our x-intercepts are, but I'm just going to go ahead and menu, trace, graph trace. So I said one of them was going to be 6 and one was negative 1, right? Well, there's one that's negative 1. There's one that's negative 1, and the other one, one of these days it'll show up. A little bit of latency between my computer and the calculator. 6, okay? So our answers here are x equals 6 and x equals negative 1, okay? Now, does anybody see where those answers could have possibly come from? Okay, if you do, that's awesome, because that segues perfectly into the next section, okay?
Teachers, at this time, if we could have any sophomore that needs to do retakes, please report to the comments.
All right, so let's move on into the next section of this then. There's this idea called the zero product property. It's one of those things that sometimes is overlooked, but it's really critical to understand how it works. The zero product property says for any real number, A or B, if A times B equals 0, then either A equals 0, or B equals 0. It's called the zero product property. It's a really useful tool in solving quadratic equations. To be clear, it's not called the 14 product property. It's not called the 13 product property. It's not called the -6 product property. It's called the zero product property. Okay? So the implication is we're going to have to get some things. We're going to have to get some things that might or might not be multiplied by each other. We're going to have to get some things set equal to 0. Okay? So that's a real important facet of this, that we have to get some stuff, preferably two things that are multiplied, and set them equal to 0. All right. Are there any questions before we look at this one, before we see it in action? Okay. So, example 3. Solve 2x plus 1 times 3x minus 5 is equal to 0. So that zero product property tells us, if I think about it, it says if A times B equals 0, then either A equals 0 or B equals 0. So the implication for this particular problem, the insinuation, is that this 2x plus 1 is kind of like our A, and this 3x minus 5 is kind of like our B. So the deal is we can take each one of those linear factors. We can take each one of those linear factors and set them equal to 0. 2x plus 1, we can set that equal to 0. 3x minus 5, we can set that equal to 0. And now we've got two equations that are linear, and we all know how to solve linear equations, I hope, right? So if we go ahead and solve this one here, let's see. I guess we'll subtract 1, so 2x equals -1. And then what do we got to do? Divide by 2. So our answer then to this equation is that x equals what? -1 over 2, or -1/2. Good. And then if we go ahead and solve this other one, same thing. We probably want to add 5. So we'll get 3x equals 5. And then we go ahead and divide by 3. So then we get another answer of x equals 5 divided by 3. And that's it. Those are our answers. That's it. What do you think of that one? Not bad? Now, the interesting thing about that one is in the beginning, from the onset of this one, I don't want to blank that out. I want to highlight that. From the beginning, this expression was already in a form that looks like something that we did last week with the factoring, right? So if something's already factored for us, there's really not much work to do. But if something isn't factored, well, then that means we're going to have to factor, and then we're going to have to apply the zero product property. I'll say that again. If something's already factored, well, these aren't so bad to do. If something's not factored yet, well, we're going to have to do the factoring. So let's try example 4. Let's go ahead and solve x squared minus 5x minus 6 equals 0. But this time we're going to solve this by factoring. Now we solved this one a few minutes ago by graphing, but we're going to go ahead and try to solve it by factoring now. I always say there's more than one way to the Eastwood Mall. You probably heard me say that at least 3 times this year so far. So we got x squared minus 5x minus 6 equals 0. So our goal is to get something times something equal to 0. So whatever this something is can be set equal to 0. And whatever this something is can be set equal to 0. So I guess that means we're going to have to be able to do what we did last week. So that means we're going to have to do what we did last week. Remember I've said before about how math is sequential? How what you learn one week, you got to retain it for the next week and the next week and the next week. Well, here we go. So x squared minus 5x minus 6. Oh boy, I'm just having a lovely Monday with the smartboard here. So how do we factor this? What are we looking at? What do we got to find the factors of? 6 that do what? That equal at negative 5 by adding or subtracting. So is it going to be 2 and 3 or 1 and 6? 1 and 6. This is just like the first one on the quiz the other day, wasn't it? Exactly like it. So we're going to go with the 1 and a 6. We know we got to go with an x and an x. And let's figure out our signs. Which one's got to be negative? Positive on the 1, negative on the 6, right? Cool beans. So then we could say, okay, so x plus 1 equals 0. And x minus 6 equals 0. And now we've got two equations to solve. So if we go ahead and solve this one, well, we just subtract 1, right? So x equals negative 1. And if we solve this other one, we'll add 6. So x is equal to positive 6. And there it is. I think that's pretty cool. I think that's pretty easy. If you are good at factoring. That's highly contingent on the fact that you can factor. Because that's the one that we just solved a minute ago by graphing, isn't it? Okay. So here's an interesting question. When should you solve by factoring? Question mark. When should you solve by factoring? In other words, when should you use this technique of solving an equation by factoring? This kind of reminds me of the proposition, who was buried in Grant's tomb? You ever hear somebody ask that question? Who was buried in Grant's tomb? What's it called? Someone's razors. It's on. Oh gosh, I just heard it in a movie the other day. There's this thing that says usually the answer is the most sensible solution. Who's buried in Grant's tomb? Of course, Grant, right? When should you solve something by factoring? Anybody? When you can factor it, right? When it's easy to factor. Whenever it can be factored. When it can be factored. And I might go so far as to say when it can be factored easily, because there's some things that aren't so easy to factor. There's some things that really aren't that easy to factor. But I would use solving by factoring anytime I can factor something easily. So at this point, I'm going to go ahead and ask the question, when should you solve by graphing? Question mark. And the answer I would probably use to that one is when I have a graphing tool. Whenever I have a graphing tool, like a TI Inspire. Whenever I have a graphing tool and I can't factor it, and I can't factor, and I cannot factor it. It being the equation, the expression, whatever I'm looking at. But if I can factor it, I'm going to solve by factoring every time because it's pretty easy. Well, what am I going to solve by graphing? Well, I'm going to solve by graphing if I have a graphing calculator and I'm not able to factor it. So I think that it would be a good idea at this point if we looked at a couple different ones. I want to rewind to the one question I gave to my advanced class at the beginning of the year. Solve 25x squared equals 49. I gave this problem to my advanced class at the beginning of the year. Now, there's 23 students in advanced Algebra 2. You know how many got this right? None. Not one soul got this right. So here's what 90% of students will do. They'll say, okay, let me divide by 25. Let me divide by 25. So they'll get x squared equals 49 divided by 25. And then they'll go ahead and take the square root. They'll say, okay, so I take the square root, and the square root of x squared is x. And I take the square root of 49/25. And some people might remember this, some people might not, but that's the same thing as the square root of 49 over the square root of 25. So that's 7/5. That's not wrong, but that's only half right. Mr. Engelhardt just gave a test in his pre-calc class. You know how many pre-calc students did that? 3/4 of them. 3/4 of them. So here's why that's not all the way right. Here's why that's not all the way right. 25x squared equals 49 could be thought of as 25x squared minus 49 equals 0. So now I've got this thing set equal to 0, and that's what I like. I like to have the thing set equal to 0. Why? Well, because I could do a couple things with it. I could either graph it or I could factor it, right? So if I want to graph it, I'll go to my function, and I'm going to graph the function 25x squared minus 49. 25x squared minus 49. And I'm going to graph this. And I think it's pretty clear from the graph that there's two answers, right? And they're going to be plus or minus the same thing. So menu, trace, graph trace. Negative 1.4. And positive 1.4. So x is equal to plus or minus 1.4. Ooh, so there are two answers to this. And 7/5 actually is the same thing as 1.4. But maybe we're really good at factoring, and we recognize what this is. I hope somebody remembers what that is from last week. Nice, the difference of two squares, awesome. That's a difference of two squares. So a difference of two squares is going to factor into something plus and something minus the same thing. And to get the first term, all we do is take the square root of the first term, so the square root of 25x squared is 5x. And to get the square root of the last term, we take the square root of the last term, and the square root of 49 we know is 7. So we get 5x plus 7 is equal to 0. We get 5x minus 7 is equal to 0. So we subtract 7. So we get 5x is negative 7, and x is negative 7/5. And then we get 5x is 7, and so x is 7/5. Okay, so there are advantages to being able to solve these things with a graphing calculator by factoring. The advantage is we're going to get the right answer. The advantage is we're going to know that plus or minus is a very important part of our solution, that this 7/5 isn't good enough. So being able to see things from a different perspective is very, very useful. Are there any questions so far? Okay, so there's one that's real special. There's actually two that are kind of special, but there's one that's very special, and I want to look at that one next. What were we on? 4, 5? I don't even know. 6? Thank you. My smart board and I just totally lost. Whatever. Not that. Okay. Example 6. Thank you. Good looking out. So there's 4. So this should have been example 5. That was example 5. So example 6. Solve. 4x to the squared plus 4x equals negative 1. So we're going to go ahead and solve this one. So some things that students like to do, and please don't write down what I'm about to write down. Here's what students do. They'll try to take the square root of this and the square root of this. And so they'll say, so the answer is it's 2x plus 2 equals 1. And so 2x is negative 1. And so x is negative a half. Sometimes you can actually do really horrible work and get to the answer by accident. Sometimes. That actually might be the answer, but that's not the right way to go about getting it. Not the right way at all. But I've seen that happen. I've seen people try to go to the hot dog shop and end up at the Eastwood Mall by accident. Right? Sometimes that happens. So what should we do before we do anything else if we're going to try to factor this? Yeah. Yeah, we got to add the 1 to both sides. So we're going to have 4x squared plus 4x plus 1, and that's equal to 0. Okay. So, hey, if I wanted to get somebody's attention, I would say, psst. See if that jogs any memories. Anybody know what this is? It's a perfect square trinomial. Perfect square trinomials, they're of the form a squared plus 2ab plus b squared. And when we factor them, they factor into a quantity. They factor into a quantity squared, don't they? So the deal is this is going to factor down into a quantity squared, and it's still going to equal 0. So to get the first term in it, I need to take the square root of the first term. So what's the square root of 4x squared? 2x, good. And to get the last term in it, I take the square root of the last term. So what's the square root of 1? 1. And the sign of the middle term is the sign that goes in the middle, and that's going to be a plus, right? So what do I know? And this is where it makes sense to expand this out. 2x plus 1 times 2x plus 1 equals 0. So 2x plus 1 equals 0, so 2x would equal negative 1, and x would equal negative a half. Wow, so that little square root thing, even though it was totally the wrong way to go about getting the answer, we kind of got the right answer, but that was, oh my gosh, I just dropped it like it's hot. That was the wrong way to go about getting it, but it was the right answer. And something happens here. We get 2x plus 1 equals 0, so 2x is negative 1, so x equals negative 1/2. And you might say, well, that's kind of redundant. That's like saying the same thing over. You just said that. You just said that. It's like repeating yourself. It's like saying the same thing you just said a minute ago. But it is worth noting, bless you. So the deal is x equals negative 1/2 twice. That's our answer. X equals negative 1/2 twice. When we get into chapter 5, there's this thing that says, anytime you're solving a quadratic equation, anytime you're solving a second degree equation, there's got to be 2 answers. And if you look at this, the only unique answer is negative a half, but it is an answer twice. And it means something very special on the graph. So if you're not sure about that, let's take a quick look at the graph, see what that means. So if I graph this, tab, go ahead and graph this 4x to the squared. 4x squared plus 4x plus 1. Notice I have to have it equal to 0 when I graph it too. So it's kind of interesting if I zoom in on that area. If I go ahead and zoom in right there, do you see what's happening right there where the graph goes through the x-axis? It doesn't actually go through, does it? It turns around there, and we're going to study that at great lengths in chapter 5. Okay, but do be aware that the solution x equals 1/2 or negative 1/2. It's because the graph is tangential to the curve, and we'll talk more about that again in chapter 5, like I said. So you might want to make a note somewhere. Perfect square trinomials have the same answer twice, right? Perfect square trinomials, you have the same answer twice. So there's not 2 unique answers, there's just one answer. And later on this chapter, we'll talk about that idea a little bit more when we talk about the discriminant. But that's not till a couple weeks out. So there's just one final thing I want to look at. You should have time at the end to, I hope, to get started on these. That way there won't be much homework tonight. You should be able to finish a lot of this in class. The last one, here we go. Example 7. Example 7. Solve. I put this one on a quiz for my one class. It was 6x cubed equals 54x squared. I put this Let me make that 54x. I'm sorry, 54x. I put this on my advanced Algebra 2's test. I put this on their test. And some of them figured it out. But we haven't done anything with cubics yet. I know. That's okay. We're going to in Chapter 5. So let's see if we can figure this out. What's the first thing we probably ought to do since we know the zero product property? Set it equal to 0, right? So we'll go ahead and subtract 54x from both sides. Subtract 54x. So we'll get 6x cubed minus 54x equals 0. And again, I know what you're thinking to yourself. You're thinking, self, Mr. Minnick, you never showed us how to do anything with cubics. But you do know how to factor out a GCF, don't you? So what GCF could you factor out? A 6x. Nice. So there is a GCF of 6x. So we'll go ahead and factor that out. We'll factor that out. We'll factor out the GCF of 6x. So what that's going to look like is going to be 6x times some group, and that's equal to 0. So remember, when we factor that out, what we're essentially doing is dividing each term. We're dividing each term by that. So we'll divide this by 6x, and we'll divide this by 6x. So what's that going to leave in the parentheses? X squared minus 9, right? Okay. Now, I really hope that we didn't forget our specials and we know what this is. What's that? X squared minus 9. There's two things. We're taking the difference of two squares, right? So this is going to factor down into something plus something and something minus something, right? Plus and minus the same stuff. In fact, what are we going to have there? A 3 and a 3, right? This is kind of interesting. So the zero product property says if A times B equals 0, then either A equals 0 or B equals 0. Well, I got news for you. The zero product property could be extended to if A times B times C equals 0, then A equals 0, or B equals 0, or C equals 0. So the deal is 6x equals 0, x plus 3 equals 0, and x minus 3 equals 0. So if we solve each of these, x equals 0, that's one answer. X equals negative 3, that's another answer. X equals positive 3, that's another answer. Huh. So this third degree equation had 3 answers. This third degree equation has 3 answers, and we'll be studying that again in Chapter 5. Okay. I could actually solve that by graphing, and that's it for the day. If I go ahead and hit Tab, and I make this, and I make this, maybe I can't make this. Maybe the calculator doesn't want to do anything else. 6x cubed minus 54x. I go ahead and graph that. I'll get my window back to where it should be. I said I'll get my window back to where it should be, and I can see my 3 answers. Hopefully you can see the 3, negative 3, 0, and 1. You see them on the graph? Cool. That's it. It's been real. It's been fun. I'd like to give a shout out to the future Mr. Minnick. Have a great day. See you next time. Good.